So good afternoon, everyone, and thank you for joining us with our GW4 Water Security Alliance seminars. Lovely to see so many people gathered here this afternoon. So our presenter today is Dr. David Tickner, who works for WWF UK, who all know what WWF does. But here today, David's going to introduce us to the triple challenge concept, which is a concept that WWF has initiated, and a really interesting application of that concept is in freshwaters. So Dave, I'm going to let you introduce yourself and give us a bit of background on what brought you here today, and let you start your talk.
Thanks, Isabel. Hi, everyone. Conscious it's Friday afternoon, so I'll try and be reasonably snappy. Introduce myself and say what brought me here. I wasn't expecting to have to do that. I'm slightly struggling. Thank you for the hospital pass. Well, I mean, you've introduced me. I work for WWF, have done for a number of years. Have my fingers in a few other pies as well, but that's the main one. And my role really puts me at the interface of science and policy and practice, particularly around rivers, wetlands, water resources, both here in the UK, but internationally. And I probably do more of my work internationally than I do here in the UK these days. What brought me here? Well, I think you did, Isabel. I think you invited me to speak. Isabel sits on WWF UK's programme committee, and so has a bit of an advisory role. And we've got to know each other a little bit through that. But also a key part of my role is engaging the academic, engaging scientists, trying to understand what's emerging from science, but also trying to guide research to what at least WWF thinks is some really interesting and important challenges. So I'll say a little bit about all of that as I'm on. Right, I will just try and share my screen. I hope this works. Can you see that, Isabel?
Yeah, we can see that, but we can also see the next slides. So if you want to put it in full screen. Yeah, at the bottom right. At the bottom right, next to there should be a full screen option. There you are, perfect. And Dave, what I meant by bringing you here, what brought you here, it was more about what brought you to the point where you are now working in WWF and thinking like a river, as you say.
Do I think like a river? Well, we'll see later on. So do you want a sort of a potted career summary? Is that what you're after?
That was why what I had initially asked, but it's fine. You can choose to ignore me or just go on.
I think maybe I'm conscious of time, so maybe I'll just crack on if you like. So what I'd like to do today is share with you some of this thinking around the triple challenge and also an allied concept of bending the curve, particularly as they apply to freshwater biodiversity, freshwater habitats, water resources. I mean, there'll be some science in this, but I should start with acknowledgements for, any number of colleagues who I work with who have helped shape these ideas, and also a few sort of other collaborators, co-authors, and the odd character as well, some of whom I've known, some of whom I won't. But I'll start with one character, and well, maybe it's three then. So the chap on the left is Captain Robert Falcon Scott, polar explorer, wanted to be the first man to set foot on the South Pole. Sadly failed, was beaten to it by Roald Amundsen by a matter of a few weeks, and died on his return journey. And before he died, he wrote a letter to his wife, Kathleen Scott, who's in the middle, for all accounts, a pretty remarkable woman. And in the letter, he said of their son, Peter, he said, "Make the boy interested in nature." So Kathleen Scott tried to do that, and it turns out she did quite a good job. Peter Scott is on the right there. He's the man who, as much as anyone else, helped set up the organisation I work for, WWF, also the Wildfowl and Wetlands Trust. Very good wildlife artist, Olympic standard sailor, just generally all-round horribly talented. And because I've worked for WWF for a long time, I know a little bit about this backstory, and I've always been struck by this phrase, make the boy interested in nature. Nowhere, or at no time was I more struck by it than when my son, Matthew, was born a few years ago. And I gave a seminar actually physically in Cardiff to Isabel and her colleagues a couple of years ago, where I introduced Matthew. My wife and I are very keen that he grows up with an interest in nature, among other things. And we spend as much time outside with him as possible. But of late, I've been wondering to myself, well, okay, so we want him to be interested in nature and many other people besides, but how much nature will there be for Matthew to show an interest in when he's older? All of which brings me to this. The main graph I'm showing here is the Living Planet Index. So this is produced every couple of years by WWF and ZSL, Zoological Society of London. And I liken it to a stock market index for global wildlife. What it shows is changes in average abundance of vertebrate populations around the world. And you can see I've highlighted it with a red flash. Between 1970 and the latest we can get statistics, 2016, there was an average 68% decline in wildlife populations around the world. Now, this is only one measure of what's happening to biodiversity. There are other measures, and I've included as insect graphs a couple of the others: Biodiversity Intactness Index, Species Habitat Index. They both show similar patterns, a pretty steep downward decline. And for me, this graph, the Living Planet Index, is increasingly personal, because I was born on the left-hand side of the graph in late 1969, and Matthew was born in 2015, so on the right-hand side of the graph. So just in the time that I've been alive, we've seen really quite significant collapse of wildlife populations around the world. And Matthew's coming into a world which is impoverished in terms of nature. And so that question about how much wildlife will be around for him, his peers, other young people to enjoy going forward is both a professional one for me, but also an increasingly personal one. And I'll say a bit more about that later on. Second part of my talk, after that little bit of an introduction, is specifically getting into freshwater biodiversity and around this idea of an emergency recovery plan. But let me start by talking more broadly about what some conservationists have started saying about how we respond to that decline in wildlife populations, that collapse of biodiversity around the world. And I should nod to Georgina Mace here, the late Georgina Mace of UCL, who did a lot of work on this. There are other people as well. Back in, I think it was 2018, Georgina and various others, including a couple of colleagues, came up with this concept of bending the curve. So if that Living Planet Index or other measures are, as lines on the graph, dropping downwards, is it possible to bend that line back up? So instead of as a global conservation movement, just thinking about whether we can slow the decline, whether we can protect some populations, some species of wildlife, whether we can protect some habitats. Excuse me, I've got an automatic on that, which shouldn't be there. Is it possible that we can actually start thinking at the global scale of actually trying to restore nature? And if so, how do we do this? So a paper was published in Nature Sustainability in 2018, setting out some broad thinking around this. And one of the key things around it was that we need to think beyond normal conservation, beyond things like protected areas. They have their place, those conservation tactics, but we actually need to start engaging broader drivers of biodiversity loss, either supply side drivers, and there was particularly an interest in agriculture as one of the main drivers of terrestrial biodiversity loss. So do we need to start thinking about doing agriculture in different ways globally, but also demand side drivers as well. So the kind of food that people want to eat, we need to start thinking about dietary shifts, for example. And some modeling was done of that, published in a paper in Nature last year, led by David Tickner from Vienna, from IASA, the Institute of Applied Systems Analysis in Vienna, which showed under different scenarios that actually it was theoretically possible to bend the curve if we combined conventional conservation solutions with these driver solutions. So there's a reason for hope there and a reason for optimism, and I'll say a little bit more about drivers later on related to freshwater biodiversity. That work was mainly done with terrestrial, land-based biodiversity in mind. I work mostly on freshwater biodiversity, and of course there are links between land and waters, and sometimes we're a little bit too siloed in the way we think. But I was a bit concerned that actually that work hadn't taken sufficient consideration of what's happening in freshwater systems. And we know freshwater systems are really important. They cover perhaps 1 or 2% of the world's surface, depending on how you count them. But they house a third of all known vertebrate species and something like 10% of all known species of any taxon. We also know that freshwater species are declining even faster than that global average. In fact, the biodiversity of freshwater systems is declining probably 2 to 3 times as fast as the biodiversity we see in forests or in the oceans. This graph is the Living Planet Index for freshwater wildlife populations, and you see there the decline is 84% as opposed to the overall average of 68%. And we see that in places like China, where the Baiji, the Yangtze River dolphin, is the first whale or dolphin species thought to be extinct anywhere in the world as a result of human actions. We see it in freshwater fishes. I read a story last year about the first ocean fish, which is thought to have become extinct as a result of human activity. Well, we think there's more than 80 freshwater fish which have become extinct, perhaps about 50 just in North America alone. And we sort of know why all this is happening. There have been some very authoritative papers, including this one on emerging threats and persistent challenges for freshwater biodiversity, which, among others, Steve Ormerod was an author of, which set out typologies of threats. So it's things like changes to flow regimes, it's pollution, it's dams and other connectivity issues, it's invasive species and disease, climate change is increasingly an issue, and a few other things besides. So back in 2019, WWF, with me as the project lead, convened some of the scientists we knew from around the world, some other conservationists from NGOs, to start thinking, well, if we wanted to bend the curve of freshwater biodiversity loss, what would that look like? And we were particularly interested to do that in time to influence some of the big international agreements which were in gestation. So things like the new global biodiversity targets, which should be agreed by the Convention on Biological Diversity in the next few months, including in a meeting in China in May. Also implementation of some of the sustainable development goals and a few other things besides. What we came up with was this 6-point action plan. I won't go through all the actions. They sort of correspond to those threats I mentioned earlier. We published that as an academic paper in BioScience last year, and happily, it seems to be getting some traction. It seems to be getting some attention, both in the research community. It's been pretty well cited. It's also spawned a bunch of other sort of offshoot papers or influenced other papers, also seeking to sort of create some critical mass around global freshwater biodiversity conservation and restoration. But perhaps even more important than influencing the research community, it's also begun to influence the global policy community. We were approached by an organization called UN Water, which is the convening mechanism in the UN family for something like 30 different UN agencies who do something or other on water issues. UN Water wanted to have some input into these new global biodiversity targets. And they wanted our help building on the emergency recovery plan. And from that, when the Convention on Biological Diversity Secretariat published its Global Biodiversity Outlook, which is a sort of a periodic report saying what's happening to biodiversity and what needs to be done to address problems, it included as one of 9 what we call transitions, a sustainable freshwater transition. And that sustainable freshwater transition was essentially a rehash of the emergency recovery plan. Now, there's a lot more work to do in terms of influencing this international system. Just because these publications have come out, it doesn't necessarily follow that world leaders will sign up to a whole raft of new, more robust targets around freshwater biodiversity. But we are gaining some traction, and I think the issue is on the table more than it ever has been before, which is a good thing. Now, all of those agreements, all of those publications are all very well, all part of influencing thinking, perhaps shifting the global paradigm around what needs to be done around freshwater biodiversity and how to adjust water management approaches, land management approaches, and other things to try and make that happen. But ultimately, the proof will be in the pudding, and it's all about implementation at the local level, the national level, the river basin level. Ultimately, that will be more important than what happens in international agreements. Many people have been saying the same thing about what's come out of 26 recently. And some work has begun now on how we downscale the emergency recovery plan for freshwater biodiversity to national contexts. And in particular, in Canada, some work has been done by some colleagues of Steve Cook at the University of Ottawa. A paper was published by Will Twadek and others earlier this year, setting out how practitioners, particularly conservation practitioners, also water management practitioners, need to capitalize on opportunities to drive the emergency recovery plan forward in their particular context in Canada. It was based on a more general framework, but they applied it, or showed how it could be applied in Canada. And I've had conversations with colleagues in WWF China, WWF Kenya, and some other places about doing pieces of work to try and do similar kind of things in those countries. Obviously, the contexts in Canada, China, Kenya, the UK, wherever, are going to be very, very different. And so we need to approach this in quite a flexible and sensitive way. But there are signs that with a bit of a push and a shove from organizations like WWF and from others, that actually the emergency recovery plan might be able to be useful in terms of shaping national approaches to the management of freshwater ecosystems and resources. I said that those kinds of efforts have to be context specific. And I can't overemphasize that point. And one of the things that we have to be aware of is that while we might want a greater focus on biodiversity in general and freshwater biodiversity in particular, of course, we have to be really conscious that biodiversity restoration is only one of the many challenges facing decision makers, stakeholders, landowners, water users in any one part of the world. And in particular, when it comes to land and water resources, what we're seeing increasingly in WWF is that there's going to be a real challenge around using land and water for either growing food or for meeting other socioeconomic needs, for restoring nature, and increasingly for storing carbon, sequestering carbon. Think about some of the debates around tree planting, for example. Now, we've done a bit of work around this to try to figure out, well, where might there be opportunities for synergy, where you can actually do all three of those, or meet all three of those goals with the same kind of land and water management strategies. But also importantly and realistically, how do you resolve trade-offs? So if there's a need to do all three of those things, but you can't do all of them with the same river or with the same patch of land, how do you make the decisions about the priorities? How do you make decisions about winners and losers, if you like? And some of that thinking was published in this report last year, which we're in the process of publishing as an academic paper as well. It's in review at the moment. I won't say much more about the concept of the triple challenge, but just to sort of give it some flavour. The triple challenge, as I say, needs to look different in different places, and the way this plays out will affect how we go about trying to bend those biodiversity curves, including for freshwater. So if we take the UK, for example, some of you will remember our last election where there was a bit of a one-upmanship between the major UK-wide political parties about how many trees they would plant. All of them included tree planting targets in their manifestos. And there's lots of analysis about where there's potential to increase woodland cover or do tree planting, allow natural regeneration. The map I'm showing here is only one of several that I've seen. Some of you might remember, some of you who are slightly longer in the tooth might remember back in the 1980s, there was another big push towards tree planting for very different reasons, especially to give tax breaks to aging rock stars, I think. And one of the reasons why that became controversial was because lots of conifers were planted in the flow country in the north of Scotland, which is a tremendously important freshwater biodiversity habitat. And I think that example shows how if you don't think through the ramifications from different policy angles, you can end up creating a little bit of a mess. And what we're hoping in WWF is that actually there will be sufficient policy integration around these new tree planting efforts to enable us to think sensibly about where trees go, such that we're still able to grow food, but also that we don't plant trees on very sensitive wildlife sites where perhaps more woodland cover isn't the priority. And also that we plant trees in a way that is cognizant of the impacts of woodland cover on freshwater resources, which can be very complex, those kinds of impacts and trade-offs. If we look at a different context, I've done quite a bit of work in Tanzania. This is a map of the Great Ruaha River catchment in Tanzania. Ruaha, in particular Ruaha National Park, which is, if you can see my cursor, just about here. For me, that's one of Africa's best kept secrets. It's one of the most remarkable parts of the planet for wildlife. Really, really important. Probably the biggest national park or biggest protected area in East Africa. The challenge is that the wildlife in the national park is very reliant for survival on dry season flows along the Great Ruaha River. Those dry season flows are increasingly being affected by climate change and in particular by expansion of agriculture further up the catchment here, and that agriculture is sometimes commercial, sometimes it's subsistence agriculture, so there are real sort of poverty dimensions to this as well as economic development ones. Lower down the catchment, we have a couple of dams which generate a significant proportion of Tanzania's electricity, the Mtera and Kitatu dams. What you've got here is trade-offs between food production, wildlife, and if you like, low carbon electricity provision. It is a different context, but very much the triple challenge. And the Tanzanian authorities and stakeholders have long struggled to reconcile these. The river is getting drier and drier. There's increasing concerns about the operation of the dams. But at the same time, the Tanzanian government wants to drive increasing agricultural expansion in order to grow Tanzania's economy, including through something called SAGCOT, the Southern Agricultural Growth Corridor of Tanzania, which very much intersects this area. So there's really sort of profound challenges there. A different context again, the Mekong. Some of you will have read about the Mekong or will know the Mekong, perhaps worked there. Again, massively biodiverse river system, arguably the second most biodiverse river system on the planet after the Amazon. Hugely important food security. 60 million people in the Mekong Basin rely primarily on freshwater fish for their protein intake. Lots of dams being built in the Mekong, again, primarily for low carbon hydropower. So again, it's a slightly different context. It's a transboundary system which adds some real geopolitics into the mix. But there you've got decisions that need to be made about balancing and trading off between biodiversity, including freshwater biodiversity, between food security, and between climate change in the context of low carbon energy production. These are sort of really difficult issues, and any attempt to implement an emergency recovery plan for freshwater biodiversity has to operate in these kind of contexts. And that's a lot of the kind of work that WWF and other organizations are doing, trying to navigate pathways through these very complex situations. That's one element of the triple challenge and one element of the emergency recovery plan. Efforts to downscale in often very challenging contexts, development contexts. Another challenge around the emergency recovery plan is around monitoring. And I'm sure many of you will have heard the phrase that if you can't measure it, it's very difficult to manage it. And I'd argue that applies here as well. Again, going back to some of these big international agreements, the Sustainable Development Goals, the CBD, perhaps UNFCCC with its increasing focus on nature as an important component of the climate challenge. All of these international agreements have monitoring systems with often quite complex rafts of indicators at different levels. And in some places, particularly around CBD and Sustainable Development Goals, some of those indicators, in theory, should take account of what's happening with freshwater biodiversity, particularly around SDG 6, around clean water and sanitation, which has some specific targets around freshwater ecosystems, sustainable water withdrawals, pollution, and CBD, which, well, I won't go into in detail here. Unfortunately, what we've seen is that in almost all instances, these international agreements, the monitoring systems for them, do a very bad job of taking account of what's happening to freshwater biodiversity. And in their defense, part of the challenge is we don't really have that many good indicators of what's happening to freshwater ecosystem health and biodiversity at a very large scale. If we look around the world, I'm currently involved in a piece of research with IMI, the International Water Management Institute, to survey river health monitoring, freshwater biodiversity monitoring around the world, with a view to mapping a pathway to coming up with a global monitoring scheme. If we look around the world, we see lots and lots of different ways freshwater biodiversity is managed. So the graph at the top here is a summary of how the Water Framework Directive works in this part of the world, with biological elements, hydrological elements, chemical, physiochemical elements, all being measured separately, and then a one-out, all-out principle, which basically says if any single one element fails, then the whole river system fails. If you look at the bottom left, this is an excerpt from a WWF publication. This is published by WWF US in conjunction with WWF Colombia, where they have put in place a project to develop what they've called a basin report card. I've seen similar things called river health scorecards, really working very much with stakeholders to first of all agree what are the dimensions of the freshwater system which are important from a biodiversity, from a wider ecosystem functioning, from a management and governance and an ecosystem service perspective. And then where can we gather data or knowledge from a variety of different sources to gauge in a very user-friendly way just how well the river system is doing. So that's much more of a stakeholder-led system than the Water Framework Directive. And what we're seeing in some countries, as an example here from New Zealand, is an attempt to sort of build on elements of all of that together, approaches which are perhaps another step forward again. The challenge with all of these systems at the larger scale they operate at is river basins. In fact, many of them operate at much smaller scales. So how do we get a sense globally or regionally of what's happening with river systems? It's a big challenge, and if we want the emergency recovery plan to really get traction, and coming up with some very policy relevant dashboard or index or monitoring system which can give decision makers, busy and not necessarily technically knowledgeable decision makers, that kind of information at a glance is a significant challenge. So this is one of the things this project is aiming to help do. There is perhaps one indicator which is beginning to head in that direction at the global level, and that's an indicator around river connectivity. Again, this was a WWF project in conjunction with McGill University in Montreal, plus a bunch of other academics from around the world. Back in 2019, we published in Nature a map of the world's free-flowing rivers. Now, the map itself was interesting and a nice communication project, but the real scientific value was the method that we developed for gauging river connectivity, at least for large rivers and very large rivers, which could be scaled. So we used it at the global level to produce a global map, but the method was deliberately designed to be scalable at the basin or national or continental level. Recently, we've been working again with McGill, with Gunter Grill and Bernard Lehner there, to try and turn that map, which is a snapshot, into a series of temporal trends. And the graphs you see here from as yet unpublished work, where we've looked back through decades of data about, in particular, when dams were built on some of these large rivers, and from that backcast, hindcast changes in river connectivity. And we can do that at the global level, we can do it at the continental level. We can also do it for specific river basins, which you can see in this middle graph here. And the nice thing is you can come up with some very nice sort of visual graphs or products, infographics of what that looks like. So perhaps I haven't portrayed them particularly well on this slide, but there's a very nice figure in the report that Gunter and Bernard prepared for us, where they take each of these river systems, about 16 large river systems from around the planet, and they produce these box plots, or these, what would you call them, histograms, and color code them according to changes in connectivity. So blue means basically free flowing. The greater the proportion of yellow and red, the greater the interruption to connectivity. And we forecast as well according to dam building proposals. And so you can see what might happen through changes in time. And it's absolutely fascinating to see the different colors on different river systems. Okay, moving on again. I wanted to go back to this idea of the driving forces of changes in biodiversity. And again, this links to some of the triple challenge thinking. So many of you will be familiar with the DPSIR framework, driving forces, pressures, state here of the oceans on this diagram, but it could be of river systems or freshwater systems, impacts and responses. I'm very interested in what's happening with some of the driving forces in freshwater biodiversity loss. My sense is that actually relatively little work has been done on that so far. But strategically, if we really want to put in place some kind of sustainable freshwater transition, to borrow the global biodiversity outlook phrase, then it's not enough to work on direct pressures, on direct management of river systems. We have to start thinking about what's driving extraction of water or building of dams or increasing pollution. Terrestrial conservationists are perhaps a little bit ahead of us on this. So going back to the bending the curve work, and that idea of working on supply side or demand side approaches to changing food production in order to bend the curve. There's quite a bit of data and knowledge about what that could look like. And there's been a sort of wider batch of scientific papers around the drivers of biodiversity loss, but most of it looking at either terrestrial, or sometimes ocean biodiversity loss. There's actually very little I've been able to find on the drivers of biodiversity loss in freshwater habitats. I got quite excited last year when I saw this paper come out, I think in Competition Letters, I should have included the citation there, apologies, by William Subiza and Apele, because it seemed to be, from the title and the abstract, looking at exactly the kind of thing that I wanted to see. But unfortunately, it seems that mostly what they've looked at is actually more the pressures using the DPSIR framework and the direct threats. So I think one of the big priorities that we need to look at as a freshwater conservation community globally and locally is really understanding what those drivers are. Is it agriculture? Is it energy plans leading to hydropower dams? Is it more linked to industrial pollution and economic development pathways which are linked to the growth of heavy industry, for example? It will look different in different places, but I think there's some great value in perhaps trying to understand that, including through quantitative assessments and through scenario assessments for the future. So I see this as quite a big research gap. So that's mostly about the triple challenge, the emergency recovery plan, and some of the ongoing research, emergency policy discussions, and research gaps around that. How do we fill those gaps, and in particular, who is going to fill those gaps in future? The quote which I used for the title of this talk came from David Brower. Brower was a very eminent 20th century US conservationist. He was the first executive director of the Sierra Club. He helped set up Friends of the Earth in the US and a number of other institutions behind. And he said, we must begin thinking like a river if we're to leave a legacy of beauty and life for future generations, which is a quote I rather like, not just because it mentions rivers. But I was doing some thinking a few weeks ago of, okay, well, what does thinking like a river look like? Of course, rivers don't think, they're not able to think, but they do behave, sometimes in quite specific ways. So if you think about a river is, I would say, quite a strategic part of the environment, in that a river is always wanting to reach its end destination, often the sea. And it's very difficult to divert a river from that purpose. But it's also quite tactical. It will pursue different paths in order to reach the sea. Sometimes it'll meander, sometimes it'll take a more direct route as needs be. Rivers are also very complex. They are multidimensional. They're not just the water, they're the sediments, they're biota, they're the people as well. They can often be unpredictable. They can change their course, or they can be adaptable. If they meet a bit of geology or a bit of human-made infrastructure, sometimes they will change their course in order to navigate their way around that. And so that got me thinking about, well, is that what Brower meant by thinking like a river? Is that what we need to do? We need to be both strategic but also tactical. We need to be adaptable. We need to be complex, or at least able to grasp complexity. Perhaps we need to be unpredictable. We certainly need to be multidimensional. And the other quote that came to mind is, in particular, actually just this morning as I was putting these slides together, was from an old collaborator of mine, Tony Allen from King's College London. Some of you might know Tony. He was the guy who back in the 1990s came up with the concept of virtual water, which has become quite influential. And I remember Tony saying quite passionately that there are two types of scientists in the world. There are empirical scientists who are interested in knowledge for its own sake. And then there are activist scientists who want to change the world. And there's a role for both types, of course. So thinking about some of the challenges around bending the curve, around the triple challenge, I'm wondering whether we need to equip a new generation of activist scientists to think like a river, to grasp the complexities of different governance and market and finance and economic systems which drive a lot of the changes to our environment and our biodiversity. To be able to think strategically about their core purpose in what they're trying to achieve, how they're trying to change the world and why, but then to be quite flexible and tactical about how they go about doing it. To have good project management skills as well as good technical scientific skills. Increasingly in WWF, at least with colleagues I work with, we're trying to get beyond the land, rivers, sea silos, get to link what's happening on the land, what's happening in the sea, often with rivers as a conduit, to combine that with some kind of better understanding of social justice elements, so that disadvantaged and vulnerable communities aren't left behind as pathways through the triple challenge are mapped. And also to think a little bit beyond science. We know that science, that facts and figures and analysis is tremendously important, but if we want to change the world, if we want to be successful activist scientists, framing narratives and stories, communication skills, influencing skills are arguably even more important. And some recent policy developments, perhaps Brexit and other things, have perhaps highlighted that fact. So we need to get better as activist scientists at combining science with those smart frames and narratives, and to do that obviously in an ethical and honest way. And I find myself wondering, from the various engagements that I've had with academic institutions, both here and internationally, whether or not the programs that we put in particular postgraduates through, whether or not they're doing enough of this kind of stuff. Very often they're very strong at the science skills, the technical skills. And sometimes, in fact, I think increasingly, some master's programs and PhD programs are paying more attention to some of these more transferable, more strategic skills. But I get the feeling that perhaps there's a lot more we could do on this. And I'd be very interested to hear your views on that as well, because you're closer to what happens with university training programs than I am. So I put that out there as a bit of a question, perhaps a little bit of a challenge as well. So, make the boy interested in nature. Increasingly, it seems to me that the boys and the girls are already interested in nature. And perhaps not just boys and girls. This was fascinating. Just the other day, a poll by Ipsos Mori on what the British electorate think are the most important issues facing the country today. And for the first time ever, environmental issues came top of the shop, and by a margin, and across different political stripes as well. Now, part of this is probably a bit of a bounce from all the media coverage around COP26. But there's been a steady increase in the amount of attention that voters or the public have been paying to environmental issues in recent years, perhaps over decades. So I'm wondering if it is entirely just a bounce, or whether actually this is something a little more durable. I'm also wondering how much of this is driven by younger people, and in particular, perhaps the younger people of a few years ago, now growing up and retaining an interest in the environment. And we've seen increasing profile of younger people in environmental debates, including at COP26. I think younger people are now a very important group of influencers on policymakers, and including on organizations like WWF, and that can only be a good thing. Greta Thunberg once said that change is coming whether you like it or not. And I wonder if that means a change to the environmental movement as well. Many of these younger people, they're interested in the science, but not just from an empirical point of view. These young people are already activist scientists, perhaps by some description. So again, it feels to me that there's a market out there for universities to train younger people in this. And if we can grasp some of that market, and in particular, if we can interest some of them in biodiversity and freshwater biodiversity, and help them understand some of the challenges around land and water resources, for food, for sequestration, for nature, then maybe there's a cause for optimism for the future. All of which brings me back to Matthew. So we're trying to make him interested in nature. We spend as much time outdoors as possible, and like lots of little kids, he loves it. He loves picking up sticks and kicking through leaves and climbing trees and all those kinds of things. He even loves splashing about in the river. And now he has a little brother, Oliver, who's 5 months old. And Matthew is already talking about going outside with Oliver, and taking him into the woods and doing all sorts of fun things together. So I'm kind of hoping that we won't just make Matthew and Oliver interested in nature. We might be able to make them into activist scientists. We might even be able to get them interested in freshwater biodiversity and bending the curve. Time will tell. I'll stop there. Thanks for listening.